Kirchhoff's second law relates the currents flowing in a closed circuit loop with electromotive forces encountered in the path. One arrives at this law using concepts of conservation of energy and the electrical potential. Consider a circuit loop such as ABCDEA. Here R1, R2, R3, R4 and R5 are the resistances encountered in the loop and the batteries with their EMFs respectively. E1 and E2 are sources of EMF in the loop. For simplicity, we will neglect the internal resistances of the batteries, although it is not essential to do so. The increase in the electrical potential in going from its negative terminal to its positive terminal is equal to its EMF. Further, under stationary conditions, the electrical potential at any point on the circuit has constant value. Therefore, starting from any point on the circuit such as A, if the potential at A is arbitrarily taken as VA, if we go along the circuit in clockwise, the potential decreases by an amount I1, R1 on crossing the resistance R1, and that the current flows in the direction of the decreasing potential. On going from the negative terminal of the battery to the positive terminal, the potential increases by an amount E1. In going from B to C, the direction of the current in R2 is from C to B. So the potential increases by I2R2. In going from the positive terminal of E2 to the negative terminal, the potential decreases by E2. This way, the successive changes in the potentials along the loop under consideration are decrease by an amount I3R3 in R3, increase by an amount I4R4 in R4, and an increase by an amount R5I5 in R5. Then taking the algebraic sum along the entire loop, we have VA minus I1R1 plus E1 plus I2R2 minus E2 minus I3R3 plus I4R4 plus I5R5 is equal to VA. Therefore, minus I1R1 plus I2R2 minus I3R3 plus I4R4 plus I5R5 is equal to minus E1 plus E2. This equation tells us that along a closed circuit loop, the algebraic sum of the products of resistances with the corresponding values of currents flowing through them is equal to the algebraic sum of the EMFs applied along the loop. This is the statement of Kirchhoff's second law.